This is the Essentials of Political Analysis. I'm Philip Pollock. In this presentation, I'd like to talk about measuring and describing variables. Well, what is a variable? In the previous chapter, we talked about concrete measures of concepts, and when you boil it all down and you come up with a final concrete measure, you have a variable. A variable is an empirical measurement of a characteristic. Every variable has only one name and at least two possible values. There's no such thing as a variable with one value. That would be what's called a parameter. As long as you have two values, you're in business as a variable. Students are often confused about the distinction between names and values, and in a minute we'll return to that confusion. Here are some examples. The name of a variable might be region. It takes on, in this instance, four possible values: south, northeast, midwest, and west. I believe the example in the book uses census divisions, which have 9 values. Another example, name of a variable, income, one name. There are many, many possible values for this if it's measured in dollars. And here are just some possible ones that you might encounter: $42,000, $40,001. Those are different values. $16,152. Here's I call it an anatomy of a variable, and there's a confusion I want to address here, and I use this particular variable for a reason. This is a variable named marital status. That's the variable name, as you can see. The values have words. I mean, the way you distinguish the values of this variable is to use words: married, widowed, divorced, separated, never married. These are the 5 possible values of this variable. The confusion arises because in computer analysis, virtually all variables, say if you're using SPSS or Stata or some other, even Excel, will have numeric codes. Here we have codes 1, 2, 3, 4, and 5. These numeric codes represent the word values of this variable. And this is a nominal variable. We'll discuss that in a moment, in which the numeric codes have no meaning except for the fact that they differentiate values that are really described by words or names. Well, here's another confusion. I find students are sometimes confused by the distinction between a variable name and a variable's values. And here's a little heuristic you can use. Think of a unit of analysis. So if you're thinking about marital status and you're studying people, you would say, what is this unit's blank? In the specific case, what is this person's blank? The word that goes in the blank is always the name of a variable. The rhetorical question, or the heuristic question, is always answered by one of the variable's values. So you would say, what is this person's marital status? That makes perfect sense to say that. That's the name of the variable. You wouldn't say, what is this person's single, or what is this person's never married? That's one of the variable's values. So the blank is completed by a variable name. The question is answered by a variable's values. If you're ever confused by that, just use that little heuristic. All right, variables come in 3 flavors, if you will, of 4 in some textbooks talk about a 4th level of measure, but in a political research, there are very commonly 3 levels of measurement or 3 levels of precision. The values of a variable tell you how precise it is. 3 levels of measurement, or degrees of precision, is another way of looking at it. The most powerful, the most precise, are interval level variables. Interval level variables have values that are the most precise. Income in dollars, for example. Ordinal level variables have values that are somewhat less precise. Approval or disapproval of same-sex marriage, survey research data very commonly uses a lot of ordinal scales, a lot of ordinal variables. And then finally, nominal level variables. So we're going in descending order of precision here, from interval to ordinal to nominal. Nominal level variables have the least precise values. They just permit you, the values just permit you to separate cases into different categories. Let's have a closer look at these. Interval level variables have values that communicate the exact amount of the characteristic being measured. When you look at the numeric codes of an interval level variable, they are the characteristic you're measuring. So you look at age and years. You'll see that coded as just age and years, and you'll say, okay, that doesn't stand for anything. That is the quantity that I'm measuring. Interval level variables use a widely recognized scale, distance in miles, age in years, income in dollars, time between coups in a country in years, that sort of thing. If you compare two units of analysis, here's a way to think about interval level variables. The values of interval level variables permit you to classify the units of analysis into different values of the characteristic, so you can make different categories. The values permit you to rank by relative amount of the characteristic. And this is the bonus with intervals, the values permit you to compute the exact difference between units. So you have all this power. The numeric codes convey the exact amount of the measured characteristic. Let's look at an example here. Two units of analysis. Person A is 21 years old, person B is 22. Look at those values. They permit us to classify person A and person B into different values of the characteristic. We know they're different. One is 21, one's 22. You can rank by the relative amount of the characteristic. You would say that person B has more age than person A. Plus, you can compute the exact difference between the units, 1 year of difference. So it's interesting, or it's useful to think about it this way, because as you go down in levels of precision, you begin to lose the ability to do the first thing that goes is the ability to compute the exact difference between units. Ordinals. Ordinals can be very confusing because they always have numeric codes. The codes of ordinal level variables communicate the relative amount of the characteristic being measured. May use a scale, but the scale measures relative amount, not absolute amount. We'll have more to say about ordinal scales here in a few minutes. Here it is. Comparing units of analysis. You can classify two units into different values of the characteristic. And you can rank by the relative amount of the characteristic. So if someone says, I strongly disapprove of same-sex marriage, and the other person says, well, I disapprove of same-sex marriage, they differ in the relative amount of disapproval. But there's no such scale of disapproval that we use to measure ordinal characteristics. For ordinal variables, the numeric codes represent relative amounts. When you look at an ordinal level variable, you want to organize. It makes perfect sense. In fact, it's necessary to organize the values from, say, less to more of the characteristic. You can't mix up the categories. But there's no number that measures the exact amount of the characteristic. Person A approves of same-sex marriage. Let's just say that's coded numeric code 1. Person B disapproves. That's coded numeric code 2. So you know that person B has relatively more disapproval than person A, but the codes just tell you the rankings. You could rank these 10 and 15. You could rank them 0 and 4, as long as the codes line up with the relative amount of the characteristic being measured. Person B has relatively more disapproval than person A, but the difference is not 1 unit of approval or disapproval. The codes just stand for relative amounts. Okay, now with nominals, the values have meaning, but only in that they communicate differences between units of analysis. May be coded with numbers. In fact, almost always are coded with numbers, but the numbers just differentiate between units. When you compare two units that have different values, you can classify into different values of the characteristic, and that's all you can do with nominal level variables. Person A is male. Let's just say that numeric code 1. Person B is female. Numeric code 2. The two numbers permit us to say there is a difference in categories here. The codes simply represent differences. The numbers have no inherent meaning. They do not represent exact amounts of gender. That's on its face doesn't make any sense. Not relative amounts of gender. You wouldn't say that females have more gender than males. Only differences in gender. Now here's a confusion I've noticed over the years. Let's take a little sidebar here. There's a box in the book that addresses this. I have been struck by asking students, for example, to name the level of measurement, level of precision of, say, a variable like age or income, which is clearly an interval level, and students will say it's nominal. And I think the reason for that confusion is the word nominal looks like number, but it doesn't stand for number, it stands for name. Students sometimes mistakenly equate the word nominal with number. Given this mistaken assumption, for example, one might misidentify an interval level variable such as age, measured by number of years, as a nominal variable. This would be incorrect. The word nominal means in name only. Thus, variables whose values are names or whose numeric codes only represent names are nominals. So if you go back to that earlier example of the anatomy of a variable, that was a nominal level variable, marital status, and you need the names in order to, the names of the values are tell you how to differentiate units of analysis. The numeric codes just stand for names.